Hi everyone, this is the Spring 2024 final walkthrough for question 6, linked list chains. So in this question, we want to create a linked list chain with a length n. Given an input list called list, we will go through each element one by one and add each to our new resulting linked list. If there are no more elements left in the input list before the result linked list reaches n, go back to the beginning of the input list to use the elements in order again. Assume that calling print on any linked list will format the values in order, enclosed by angle brackets, and you will not need to implement this yourself. So let's go through the dog tests to get an understanding of what this function should be doing. So as you can see, we are given two parameters, which is a list and a number n. And in this first dog test, we could see that our list is this element, and we want to call linked chain essentially three times recursively to create a linked list with three chains. And if we print it out, we could see that the angle brackets are here and the elements are listed in order. And in this doc test, you could see that our list has two elements, which are 1 and 2, and we want to recursively call this function 7 times. So as you can see, our linked chain will have 7 elements in it. 1, 2, 3, 4, 5, 6, 7. And we can see that every time we reach the end of our list, which is the element 2, it goes back into the beginning and starts from that element, which is 1. And then it repeats until we reach a length of 7 times. And for our last doc test, we could see that we are given an empty list. And if we're given an empty list, regardless of what number gets passed into n, we will want to return a empty linked list. So let's start with part A. And if we can see, we are trying to fill in this first blank of our base case. And in this part, we also see that we're checking to see if this list is empty. And we are given multiple options to do this check, but we want to figure out which ones are valid and which ones are not valid. So for this first option, you see that it says LST is list.empty, and this would actually not be a valid form of checking if Python's built-in list is an empty list because Python's built-in list does not have this method called list.empty. You might recall something similar, such as the linked list attribute called linked.empty, which is valid, but the Python's built-in list type does not have this method, so we can rule this one out. So for our second option, we have LST equals brackets, which represent an empty list. And this is actually a valid way of checking if a list is empty because the double equals operators is a Boolean value. So it will return true if our list is empty and false if our list is not empty. For our third option, we have LST is link.empty, and this is not valid because LST is a list and not a linked list, so it doesn't have the link.empty attribute. So we can rule this one out. And for our fourth option, not list is also a valid way of checking if a list is empty. And it also has the same reasoning as our second option, where the not operator it returns a Boolean value. So it returns true if our list is empty and false if our list is not empty. So for our last option, we have LST is brackets, and this is not a valid form of checking if our list is empty because the is operator checks if our list and the brackets are pointing to the same object. For example, if we have an environment diagram, LST and empty brackets are usually pointing to different objects, so they are not referring to the same object, which means that it will always return false, even if our LST is empty. So we can rule this one out. So our only correct options are option 2 and option 4. Now we can move on to part B, which is our other condition of the base case if our first condition is not true. So we've solved one of the most basic cases of this problem, which is when our LST is empty, but we also want to figure out a point where we want our recursion to stop completely and return a value. And we want this to happen when n is equal to 0. Because when n is equal to 0, we want to return an empty linked list since we don't want to add any more elements into the linked list. So that goes on to part C, where, as you can see from this doc test, linked if our list that we are passing in is empty, we want to return an empty linked list. So we can do that with link dot empty. Now we can move on to part D. And from the skeleton code, you can see that we are actually making the recursive call here. And if you recall, with our function, we are passing in a list and a number. And I'm kind of working backwards here, but we want to keep decrementing our number n until it reaches the base case of 0. So the most intuitive way of doing this is by subtracting 1 from n every time we make a recursive call so that we eventually reach the base case. So that is part E, but we can kind of come back to part D. And in part D and E, we are building the rest of our linked list, as you can see from the hint of this variable name. And if we recall from the problem, it says that if there are no more elements left in the input list before the result, linked list reaches length n, we should go back to the beginning of the input list to use the elements in order again. So we can kind of see from this example, which has the element 1, 2, we want to kind of take this element and attach our 1 back onto this element. So that would be our first recursive call. And in our second recursive call, we want to take this element and bring this element to the end of our list. And we want to keep kind of doing this implementation until we reach 7 calls. So we could do this with list splicing. So we want to start with all of the elements starting from element at index 1 all the way to the end of the list. So we could do that with list 1. And just a reminder that the 1 is inclusive, and if we don't mention a number behind the colons, then it will take everything after the 1 to the end of the list. And we want to attach this element to the end of the list by adding the element at element 0. And we can't just put it in this form because it would then be invalid, as when we splice a list, it essentially returns a copy of that list. So in this case, it would return 2. And if we say list of element 0, we would only be add 1. And a list and an integer can't be added together. So we want to turn this integer into a list. And we could do that just by adding brackets around that. So that is for problem D. Could write list. And finally, for part F, we can see that the variable is inferring that we want to create the first element of the linked list. And since link underscore rest returns all of this, we want this element. So it would just be the first element of the list that we pass into LST, which is the 0th element of LST. And we don't want to put our brackets around the 0th element LST in part F, because if you can see from the return statement, LNK underscore first refers to the first element of the list. So if we print it out, we aren't getting brackets around the first element or any of the other elements. We're only getting the element itself, which is one or the face. Okay, so now we can fill out the rest of this. Said that part B is n equals 0. Part C is link dot empty. And part D was one F is. So that is it for question 6, linked list chains. Thank you for watching.